Welcome to today's daily cybersecurity briefing. I'm really glad you're joining us for this deep dive because, well, the sources we have today are honestly a bit unsettling.
Yeah, unsettling is definitely the right word for it. It's quite a stack of stories we're looking at.
Right, so to give you an overview, our mission today revolves around this central, frankly chilling theme, which is threat actors weaponizing the exact tools we trust to manage, build, and deploy our software.
Right.
We've got three main stories on the docket. First, a critical flaw in FortiClient EMS that's pushing credential stealers.
hmm
Second, an unpatched zero-click remote code execution bug in the Gogs Git service. And lastly, a huge wave of supply chain attacks hitting NuGet and NPM, which, and this is the crazy part, are actually being amplified by AI search tools.
Yeah, that last one is wild.
Yeah.
But, when you look at all these sources, the technical expertise required for these attacks, it varies wildly. Like some are basic, some are highly sophisticated.
Right, totally different skill levels.
Exactly. But they all exploit this one fundamental flaw in modern IT,
Yeah.
which is our blind, implicit trust in automated systems.
Absolutely. So let's jump right into the first story, the FortiClient EMS betrayal. So Arctic Wolf recently caught attackers exploiting CVE 2026-35616. This is a critical pre-authentication API access bypass in FortiClient endpoint management server,
Right.
and it has a CVSS score of 9.1. Fortinet did patch this in version 7.4.7, but attackers were seen exploiting it in the wild in May of 2026. So what's actually happening here?
Well, to grasp how bad this is, you kind of have to understand what an endpoint management server, or EMS, actually does. It's essentially the central nervous system for your endpoint security.
Okay.
It talks to all the FortiClient agents on laptops, servers, desktops, you name it. It pushes updates, sets policies, all that.
Yeah.
So a pre-authentication API bypass basically means an attacker doesn't need a username, they don't need a password.
No MFA token, nothing.
Nope, nothing. They just start issuing commands directly to that central nervous system, querying the API just like a real admin would.
Reading this, the analogy that kept coming to mind is it's like a building's security system getting hacked. So the security guards unknowingly just hand out the burglar's master keys to every single apartment, totally convinced they're just doing a routine lock update.
That is a perfect way to put it. The defenders effectively become the distributors of the attack.
It's wild. And Arctic Wolf noted that the attackers were super methodical. Like, they didn't just smash and grab. They went in and modified the EMS configurations to actually defer the firmware upgrade reminders.
Yeah, they literally told the system to stop reminding users to update, just to keep their exploit window open.
Wow.
And then they altered a remote access profile and an endpoint policy to push malicious PowerShell commands. And because the endpoints trust the EMS implicitly, if the EMS says, hey, run this script, the endpoint just runs it. No behavioral warnings, no red flags.
Because it's coming from the boss.
Exactly. It's a sanctioned, highly privileged management application.
Right. And the payload execution itself is so tricky. So the sources explain that it starts with a legitimate executable, FortiTrade.exe. And since that's trusted, your EDR tools are way less likely to flag it.
Right. It blends right in.
Then FortiTrade.exe launches a .cmd script, which calls a base64 encoded PowerShell script. And that script downloads something called FortiEndpointPatch.exe.
Disguised to look like a totally normal update.
Exactly. But it's actually an unreported Windows information stealer going right after Chromium and Gecko browsers for passwords, cookies, credit cards, all of it.
And here is the really fascinating technical quirk about that specific stealer executable. It completely lacks network exfiltration capabilities.
Wait, really? None?
None at all. It has no code to send the stolen data out to the internet.
Okay, but that seems completely counterintuitive. Like, the whole point of an info stealer is to send the data back to the attacker. Why build malware that can't even phone home?
It's a deliberate choice to bypass EDR network monitoring.
Oh, I see.
Yeah, because if a random unknown binary suddenly starts sending data over port 443, the firewall or EDR is going to flag that immediately. So they built the stealer to just silently write the harvested data to a local log file buried deep in the program data directory.
So they separate the collection phase from the exfiltration phase.
Precisely. Once the data is on the local disk, the original PowerShell script, the one that started the whole chain, takes over. It reads the local file and transmits it via an HTTP POST request to an IP address. I think in this campaign it was 83.138.53.110.
And because administrators use PowerShell all the time for network scripts, the EDR just ignores the outbound connection.
Exactly. It's much harder to classify that as malicious without creating a flood of false positives.
That is so clever. And we really need to talk about what they are stealing because it's not just passwords. The fact that they're targeting session cookies is a huge deal for you, the listener, in terms of practical impact.
Oh, absolutely. Passwords can be changed, right?
Right. An MFA can block a leaked password, but a session cookie is, well, it's a pre-authenticated golden ticket.
It's cryptographic proof that you've already logged in.
Yeah.
If they steal a valid session cookie for your Microsoft 365 or your cloud infrastructure, they just drop it into their own browser.
Then they're in.
They completely bypass the MFA prompt, so compromising the endpoint manager gives them a free authenticated pass to the user's entire cloud environment.
Which is terrifying. And, if attackers are getting that much leverage by compromising endpoint managers, it totally makes sense that they're also moving further upstream. Like if you can't hit the endpoints, you go after the source code before it even gets to the endpoints.
Right. Which brings us to the second story.
Yeah, the massive fire currently burning in the Gogs ecosystem. So Gogs, for those who don't know, is a lightweight open source Git service. Companies self-host it, kind of like a self-hosted GitHub.
Mm-hmm.
And Rapid7's Jonah Burgess just found a critical vulnerability, CVS score of 9.4. It doesn't even have a CVE yet, and it's been sitting unpatched since March 17th, 2026.
Yeah, an unpatched 9.4 sitting out there for months is basically a worst-case scenario.
Definitely.
To understand this one, we have to talk about how Git handles project history. Specifically, the difference between a merge and a rebase.
Right, the classic developer debate.
Exactly. So a standard merge preserves the exact history, but rebasing actually takes commits from a feature branch and replays them one by one on top of the main branch, so the history is perfectly linear.
But let me jump in here because I'm looking at the source and I have a question. The git rebase command has this exec flag, right? And that allows a user to run a shell command after each commit is replayed.
Yes, that's a built-in feature.
Right. Developers use it legitimately all the time to run test suites and stuff. So isn't the vulnerability just that Gogs completely failed to sanitize the branch name input? Like, it sounds like a basic failure of validating user input rather than some highly sophisticated exploit.
You're totally right. That's the exact mechanism of failure. The underlying Git software is just doing what it's told. The flaw is that Gogs takes untrusted user input, the branch name, and just blindly passes it to the system shell.
Wow. So they don't sanitize or escape special characters at all?
Nope. So the attacker just creates an account, creates a repository, which automatically makes them the owner, and then toggles the rebase merging setting.
And then they just create a pull request with a malicious branch name and boom, remote code execution.
Zero interaction from a system administrator required. The blast radius is just immense.
And there's already a Metasploit module for this from Rapid7. So the barrier to entry is basically zero. The module automates the whole thing. It creates a temporary repo, runs the exploit to get shell access, and then just deletes the repository.
Leaving almost no forensic evidence.
Exactly.
Because when the attacker deletes the repo, the web app doesn't log it as a security event. The server just throws a generic HTTP 500 internal server error.
And for a SESOC team, looking for a random 500 error is like finding a needle in a haystack. Web apps generate those all day for benign reasons.
Right. And once they have remote code execution on that server, they have the keys to the kingdom. They can access every repository, dump credentials, and silently tamper with source code.
Which means if you have multiple teams sharing a Gogs instance, it's a massive cross-tenant data breach.
Yeah, an attacker can read everyone's private code. So if you are listening to this and you're running one of the roughly 1,141 internet-facing Gogs instances.
Or even one internal behind a VPN.
Exactly. You need to act immediately because there is no patch. You have to lock down your app.exe configuration file. First, set disable registration true.
To stop them from making that initial account.
Right. And second, set max creation limit equals 0 to restrict repo creation. Finally, you have to audit all your existing rebase merge settings. Until there's a patch, assume that feature is an active threat vector.
Okay, so we've covered the management systems and the code repositories. Let's move to the third story, which might be the trickiest part of modern development: external libraries. The software supply chain.
Oh, yeah. The package registries.
Right. So Socket recently found a highly malicious NuGet package masquerading as a C# SDK for Cube. And Cube is a major Brazilian financial system. The package was called Cube.sdk, versions 2.0.0 to 2.0.4, and this thing is nasty. It steals client IDs, PFX passwords and base64 encoded PFX certificates and sends them to a hard-coded Sentry endpoint.
Yeah, those PFX files contain the cryptographic keys used to securely authenticate businesses with the banking network.
It even captures the raw Boleto API responses, exposing transaction detail.
It's essentially a skeleton key to impersonate a business on the financial network.
Right. But here's the most terrifying detail from the socket report. The way developers were finding this malware was through AI. Google Search AI mode was actually surfacing this malicious package as a legitimate library. And the attackers kept their GitHub repository completely clean, but uploaded the malicious package to NuGet. So my question is, if AI is recommending malware and attackers are faking clean GitHubs to pass the smell test, how on earth are you supposed to trust anything you download?
That is the big question. It's what Sonatype is calling manufactured legitimacy.
Right.
We are way past simple type of squatting now.
Right. No more naming a package React with 2 E's.
Exactly. Attackers use version mimicry, they embed target terms, and they exploit source-to-package mismatches. The AI sees the clean GitHub, decides it's relevant, and recommends it. It doesn't actually decompile the binary sitting on NuGet.
It's hallucinating safety based on a facade.
Right, and we're seeing this explode on NPM too. The Microsoft Defender team found 14 malicious NPM packages published by a single actor under the handle VPM-dhudge.
And those were targeting AWS and HashiCorp Vault secrets, right?
Yeah. They use pre-install hooks. So basically, when a developer runs the install command, the package manager automatically executes a script before the package is even fully integrated.
It just runs it in the background.
Yep. And it grabs environment variables from process.env, parses .npmrc files, and hunts for cloud keys.
It's so aggressive. And the evolution of this is what Blue Voyant researcher Michael Warren was talking about with Team PCP, also known as replicating Marauder.
Right, the worm-like expansion.
Exactly. They're exploiting automation to turn an isolated software poisoning event into a reproducible spread. You pull a poison dependency into a container image, and then your CI/CD pipeline pushes that compromise exponentially further downstream.
It uses the automated workflows against the victims. So if you install that Sekub SDK, treat all PFX material as compromised immediately. Rotate your passwords, audit API logs.
Absolutely. And for everyone else, this has to be a wake-up call to stop blindly trusting package manager automation.
A clean GitHub repo means nothing. An AI recommendation means less than nothing.
Right. Okay, let's quickly recap our primary takeaways from the daily briefing today. Number 1, upgrade your FortiClient EMS to version 7.4.7 or later.
Got to close that API bypass.
Number 2, if you run Gogs, manually lock down your repository creation settings right now.
Yep, disable registration interest.
And number 3, you have to deeply scrutinize your open source dependencies before your CI/CD pipeline just blindly ingests them.
Which really leaves us with a provocative thought to end on today.
Oh, let's hear it.
Think about our entire software ecosystem. From endpoint updates to Git rebases to package installations, it is all built on this assumption that automation is inherently good because it saves time.
Sure, it's efficient.
But if threat actors are now specifically weaponizing that automated trust to achieve this worm-like spread, do we need to fundamentally rethink the concept of automation in cybersecurity?
Oh, wow. That's a huge question.
Right, like is the true future of secure development actually less automated?
That is a lot to mull over. If efficiency is the vector, maybe we have to slow down to stay safe. Well, thank you so much for joining us for today's deep dive into these sources. Keep questioning those automated systems, stay curious, and stay secure.